All right, guys, we are live for the third OpenMined State of the Community. We're going to be going over a bunch of demos today. We have a couple just general statistics that we'd like to go over. A lot of things to change. And Andrew, I'm going to need a little bit of help with this. We now have, what is it, over 1,100 people on Slack? 1,100?
Yeah, just past 1,100 today.
Yeah, I think in our last video 2 weeks ago, we had somewhere around 450, 500. That's obviously a pretty big jump. A lot of that jump actually was due to Suraj. Suraj put out a video kind of explaining the OpenMined community, and we'll link to that in the description below. But that was awesome, and we just saw a huge flood of people coming in to Slack and asking questions and getting involved. We are now up to 307 pull requests. We've got a newsletter that we're putting together. We're going to do weekly or bi-weekly newsletters. Let's see, we have now 50 GitHub members, contributors, and GitHub stars, we have somewhere around 620, 28, 30, somewhere in there. And very recently, I think 2 days ago, yesterday or 2 days ago, we were #1 trending on GitHub for Python, and number 14 trending for just all languages. So that's pretty huge. Andrew, anything you want to say about that?
No, just I'm very excited to see all the growth, and everyone, since there's so many kind of new folks around, please be really considerate and help. I guess the 600 or so new folks that are around to kind of learn about the project and on all of its little pieces. So yeah, the real trick here is just figuring out how to welcome a large group of people into our community. So it needs everyone's help, and I'm very grateful to everyone who's been answering questions in the beginner Slack channel and in general discussion as well. So welcome everybody.
A lot of good kind of growing pains.
It needs everyone's help.
Yeah. Well, cool. All right, let's dive into some demos. Adrian, I believe, is up first. He's got a sneak peek of Ethermint.
Hey guys.
Hey.
All right. Actually, let's find out how to share my screen.
Hey, Adrian, you want to start by introducing yourself?
Yep. Give me 1 sec so I can do the screen sharing first. Share the screen, sure. Yeah. So hi guys. I'm the core developer on Tendermint, or one of the core developers for Tendermint. I'm building Ethermint right now, and I'm also head of community for Tendermint. So I'm doing a lot of this community outreach, teaching people how to use our platform, how to use Ethereum, releasing videos and blog posts, writing a lot of code. That's pretty much my day. Yeah. Anything else you guys want to know about me?
Rock and roll.
All right. So you can see the main screen right now. Okay. So what I'll be demoing today, sorry about that, is Ethermint. So Ethermint is the EVM, so Solidity and all the normal Solidity tools, running on proof of stake. And so running on Tendermint Core, which is the proof of stake consensus engine. I currently have this running here. So in order to get this running, you need to install Tendermint. Actually, if you can't, can you see my screen?
Hey, Adrian, if you have multiple screens opening, the one that we can see says Ethereum Gas, how it works.
All right, that's the wrong screen.
There we go.
Wait, all right, you can see. Okay, then I'll do it on this screen. There we go. All right, so there are 2 things to it, right? So 2 things to running Ethermint. So the first thing you need is you need to install Tendermint, and I'll post some links on like how to install it after this call. Yeah, which I can show you here. Yeah, 2 screens are very confusing in the demo. So yeah, just install Tendermint, and the instructions are pretty clear. I'm not going to go through it because it takes a while. We have binaries, or you can install from source. And then there's also Ethermint, which you need to install. And the logic is, the split means that Tendermint itself handles consensus and peer-to-peer, and Ethermint is literally just the EVM. And by the way, so Ethermint runs at 200 transactions per second. If you need speed and more capacity, Ethermint is your friend.
So and what Adrian's saying here is that if you need more speed or capacity than the Ethereum blockchain and the Ethereum virtual machine can give you, then this is a hyper fast blockchain that runs very similar technologies.
Yes. Right, you can still see the screen. Okay. So this looks slightly confusing right now. So this is starting Ethermint and unlocking 10 accounts at the same time. I'm still figuring out how to do this the best way because so we need 10 accounts that the demo can access, and I hopefully find some way around this. Especially because now you have to unlock all these accounts. So this is kind of annoying right now and not as nice as with test RPC, where it just gives you like 1,000 accounts.
But that's why this is a sneak peek.
Yeah. So if you're interested in usability, this is a good place to start. This is first account unlocked, second account unlocked, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. All right, no, that's already enough accounts. Perfect. So now Ethermint is starting up, and you can see every time there's a new line, a new block is produced. So block times is like roughly 2 seconds, mostly 1 second actually. And just to show you that actually works, I have a bunch of tests here. So truffle tests that I can deploy with NPM. And this just deploys 3 smart contracts.
It's a really big account balance you got there, sir.
Oh yeah, like that. Oh shit, did I just kill it for you guys? Yeah, there. So the 3 smart contracts. This is just to like, it's standard EVM. And by the way, you don't need to change anything in the code you run. It just accepts everything over Web3, so over the HTTP endpoint at 8545.
So any contract you can run on Ethereum, you can also run on this Ethermint technology. However, it runs 20 times faster, which is part of the reason why we're excited about it here at OpenMined.
Exactly, yeah. And of course, so you can easily modify the maximum block gas limit and things like that. So currently I'm running, by the way, with double the amount of gas per block than standard Ethereum runs. Because it turns out that the smart contract that we need to deploy is like a quarter of a block. It's like 1 million gas under standard Ethereum. Yeah, so now this is actually the simulation. So this is the decentralized learning. And this is only a sneak peek, so we're only going to go up until the end of step 1 here. Because we're still figuring out some decoding issues, but those should be done next week. And like, if you're interested in actually working with this, just let me know on Slack, and we can talk.
Adrian is at Adrian on Slack, in case anyone doesn't know.
Very easy. Yeah, so here we essentially, I deployed this the smart contract before. Actually, I can show you that even the deployment works. Give me 1 sec to find it. It's in code. OpenMined. So right. Yeah, truffle. And so this is now, yeah, the network is up to date since I deployed the contracts earlier. So this is now pointing to the model repository contract on Ethermint. I have IPFS running in the background as well. And these 2 technologies interoperate without any problem, by the way, except the mentioned decoding error. So we can run this. This. And now we're submitting our model. There we go. And the last step. This is our model now. And here I wish I could show you more, but there is some issue where Ethermint gives us back something that we're not expecting, and hence we're decoding it the wrong way. And so we end up getting a malformed address here. But yeah, you can see you get a classifier back here. Yeah, that's pretty much it. Yeah.
That's awesome.
So this, by the way, this even though this we can't show the rest yet, this shows that we can store an address, an IPFS address on Ethermint, and then retrieve a corresponding model afterwards. And so we have the fix. We just need to propagate it throughout the code base. We figured that out tonight. Yeah, this is pretty much it for my demo. I hope you enjoyed it.
Great, awesome, cool. Andrew, I think you're up next.
Yes, I am. There happens to be a fighter jet flying over my my house at the moment, so sorry for the noise.
Quick question. How do I over it?
There we go. All right, so can you see my screen?
Yeah, you're good.
Awesome. So yeah, I live in Oxford, but there happens to be a massive United States Air Force base not too far away. So there's like big jets and stuff that fly over all the time. Okay, so one of the very exciting developments in the last, since the last video has been the development of a new type of tensor. And it's still kind of in a prototype phase, but for many of the people who are familiar with OpenMined, you'll be familiar with the fact that we've been using homomorphic encryption to sort of protect the weights of our models, or to hide the weights of our models under certain scenarios. And what makes this homomorphic encryption very special is that one person can take a model, encrypt it, give it to another person, and then that person can actually run the model and train the model without ever having access to the values of the weights inside the model. However, there's another form of this kind of protection where we're protecting the weights inside of a machine learning model, inside of a neural network, but that does not use encryption. Instead, it uses a very special type of process called multi-party computation. And what multi-party computation is all about is, let's say we want to hide one specific number, right? We're going to split it into three things, which is called 3 shares, right? So if I have the number 5, I might split it into 3 shares, which will look like random numbers. It'll be, 20,563, 53,597, and another really big number. And so what I can do is I can take an individual number and I can split it into different shares and give those shares to 3 people that I trust. So in this case, we're going to say that's Bob, Alice, and Sam, right? So when we fire up what's called a multi-party computation repository, what we're going to do is we're going to elect Bob, Alex, and Sam, 3 different people to hang on to one of those shares for each integer that we want to initialize. So in this case, whereas Bob, Alice, and Sam are all kind of living inside of this notebook, when we get beyond the prototype, Bob, Alice, and Sam will actually be 3 people, 3 computers, who we assume don't have access to each other's computer, right? So we assume that Bob's in Croatia, Alice is in Australia, and Sam is in Siberia, right? And each of them have their own machine. And what we do when we want to encrypt, a number, we split it into 3 shares using this special process, and then we send 1 share to Bob, 1 share to Alice, and 1 share to Sam. And the nice thing is that no one can actually figure out the value of the number that we're trying to protect unless they can get the shares from Bob, Alice, and Sam, right? So let me show you a little bit what I mean. What we've built here is basically a simulator for multi-party computation in the form of a tensor. Okay? So if you remember, let's create a vector, right? So we're going to do numpy.array 1, 2, 3, 4, 5. Okay. So now, what this just did when I created this tensor, it said, okay, Alice, one of these 3 people, wants to create a tensor, right? So it initialized 1, 2, 3, 4, 5 different numbers, and then it split them. Each of these numbers it split into 3 different shares and sent one of those shares to Bob and one of those shares to Sam, right? So behind the scenes, when I have this tensor object, is actually 3 different people that are hanging on to it. And the person who created it is Alice, right? So Alice created this, I'm Alice in this particular case. I guess I should rename it Andrew. Andrew. Okay, Andrew. Cool. Whoa, get back here. We'll go with Alice. Apparently it was unhappy with that. Great, so we have Alice. It created a 5 different numbers. As I said, this is a proof of concept, so it's just kind of to show how it's going to work. We have this one individual tensor. Behind it, 3 different people are hanging on to the different shares. So the cool thing is that Bob doesn't know the value of this tensor. Sam doesn't know the value of this tensor. And the only reason that Alice knows the value of this tensor is because she has the authority to ask Bob and Sam for it. That's actually what it means for her to be the creator, right? So when I actually say, when I print this, right, when I say, print R, it actually goes to Bob and Sam and says, hey, Bob and Sam, show me what the value of this tensor is, right? So if I were to do R plus, X equal to R plus R, and then I want to know the value of X, it's behind the scenes, Bob and Sam both did what Alice said and added their shares together in the correct way, such that when Alice then goes and asks for the result of that computation, give me these shares so I can figure out what the tensor is, she's successful, right? So the cool thing about this operation is that we can now do math on numbers that Bob and Sam cannot see, but they can help us perform computation on it. And in fact, if Bob, Alice, and Sam had each been given their shares not generated by Alice, none of them would know the values of the final operation. They would only know the value of the share that they can see. So that's the demo of multi-party tensor prototype. There's a lot of progress we want to do with this. There are many of the normal tensor operations that we want. You cannot actually do with this tensor yet, but this is kind of the basic prototype, so you can go into the PySafe repository and see generally how it works. It's based on this awesome blog post that Morten Dahl put together. So if you want to take this to the next step, first off, help us add more tensor operations. I'm not showing you the ones that don't work yet because we haven't built them yet. And then we also want to set up Capsule so that Bob and Sam can actually live inside of Capsule and will interact over the network so that we can, via socket connection, so we can test out performance. So thank you very much. That's my demo for this week.
Sweet. That looks awesome. Devashra, I think you're next. You want to go ahead and unmute yourself.
Okay, so am I audible to everyone?
So yeah, we can see you.
Can you hear me? Okay, so hello everyone, this is Deveshwar and I'll be demoing the PyBV and PyAsh repository today. I'll be going through that each API currently provides. Okay, so this is a demo that I have created for the BV repository. If you watch the last demo that there was a statement here. He may call a function, but there's no need to do that because I have made it so that when you do the import, it really calls that function. So I'll start with what the classes are. So you said the party class.
Hey, Devashra, we can actually only see your Google Hangout screen. I don't think we can see anything other than that. Are you showing it on a different screen?
Yeah.
Okay. Yeah, you may need to switch screens that you're presenting.
I create many workspaces to see that. We'll switch to them.
Yeah.
So. Yeah.
If you want, we can actually come back to you if you want while you're getting that figured out. What we'll go ahead and do, we'll go to Robert. Are you available? Are you good?
Yeah, I can talk.
Right on, go for it.
Okay. My name is Robert, and I code a lot. And Trask invited me to check out this interesting project, and yeah, just when I see a challenge, I gotta win.
Hey Robert, can you show us the SIF stuff you've been working on lately?
Yeah.
Excellent.
So here's the so in particular, my interests are in the JavaScript part of the app overall. And so I put together a very small code presentation to kind of outline what I'm doing and how we're accomplishing that. I'm hoping that works. So anyway, our end goal, we want to translate PySift to sift.js somehow. And we were kicking around a bunch of ideas originally. And so to keep it short, we want something that accepts a Python string in, converts that string to an abstract syntax tree, and then we want to cast that abstract syntax tree to something that looks like ES6 in JavaScript, abstract syntax tree, and then finally out to JavaScript. So that's kind of the difficult task at hand. And the reason that we're doing it like that so far is to minimize our technical debt. And you know, we don't want to have developers just working side by side, limiting the amount of what's the word? The free flow of ideas, I'll say. And so to facilitate that, you know, like we'll have Python, we'll accept Python, but we'll want to make it simple to get clean JavaScript out of that. And then anytime there's a commit made, we want to basically do it automatically. And not only that, we want to not just have, you know, CPU code, we want to as well have it run on GPU. And we want it on mobile, web, and Node. This has not been accomplished yet with the code in here, but GPU.js allows us to do that fairly easily. And so that's sort of the target. And so with that in mind, I'll go ahead and run real quick what we have. This is Sift Translator. That is OpenMined Sift Translator.js. There's some issues that you could potentially open. The initial one was to run the thing. So I'll do that. Node index. I run this. It goes through all the files. First off, it syncs Git so that we have the latest PySoft. And then we pull. And then back over here, we iterate through all the files that we've got. We create their string. Then we parse those using Filbert. Filbert is a Python to AST translator. So it basically just gets a universal language and that's happening. Then we take that AST and we actually put it in an output folder. So we've got like the entire project. You know, we can actually look and see the abstract syntax trees of each one. It kind of helps to debug currently. Next, we convert that AST using a cast method, AST cast. And the AST cast is, it looks a little complicated right here, but essentially it looks for rules and takes whatever rule applies to whatever part of a abstract syntax tree and then alters it. And then it recurses as well. So you can see it's calling itself here on various parts of the abstract syntax tree. The actual method for converting is actually fairly simple. Currently we have just a few sort of proof of concepts like substring, wrap, replace, and unnest body. And to show you how we define like how this actually works, this is the configuration that we currently have running on the entire code base. So for any file that has a type of literal that matches 3 quotes, we're going to substring it by 3 characters on the beginning and 3 on the end, and then we're going to wrap it here with these arguments. If you have a logical side of you, you've probably deduced that we are replacing Python comments with JavaScript comments. That helps, you know, the files to not explode. And then there's, you know, additional ones for specific files. For example, here we in the basic.py on the program we unnest the body. We were getting like just a giant object when it parses to JavaScript. And so that's how the configuration works. And finally, here's our output. It's not beautiful just yet, but it is an output, and it is in JavaScript. And so the next goal is to get it looking prettier and to make it work. Some of the added tasks that we have over here in OpenMined are to essentially get it to compile, get it to run unit tests, and then get it running GPU. And I jokingly put this out, compile and run GPU output to outperform its Python counterpart, but you have to have a goal. So yeah, that's pretty much it for my presentation.
I like how they're all Hacktoberfest too. If anyone's, feeling a bit antsy, more than welcome to jump in. That's awesome there, Robert. Thanks.
Yeah, no problem.
Cool. Dipanshu, are you good? You've got the final demo. I believe the floor is yours. And you've got a fuzzy microphone, so.
Oh, yeah. I'm here. Hi. Can you hear me?
Yeah.
You're good. Your phone is vibrating now.
All right. So I've been working on the noise tracking issues on failure as of now. And so here's my screen. My screen's here?
Yeah, you're good.
All right. So I'll be demoing a basic tracking of the operations like additions and multiplications on the tensor objects, the encrypted tensor objects, so that seeing the depth of the operations, we can predict how much noise the tensors contain. So, all right, I'll just show what I mean by noise here. So let's just generate a key pair, and this is the default key length, so you could ignore that. All right, so for additions, I make these arrays of ones and zeros, and in this loop, I add them up continuously, and it breaks when the decrypted version, these are all ones, so I'm just adding ones and ones and ones. So after decryption, it's easier to see when the decryption breaks. So let's just run this and see how far this goes. So for multiplicative depth, additive depth of 300, 400, this one just keeps going on and on. I've tested this for more than 400,000 at least. So.
Wow, really? That's incredible.
Yeah. So, but this is just adding ones and zeros, right? So the amount of noise added per computation is pretty low. So that's why I think it probably goes that far. So, but if we add, if we double the amount of noise every computation, it goes pretty low. Let's see this one. So here I'm adding ones and ones. So this is a tensor A is ones, and then I assign it to C, and then inside this loop, C just keeps doubling every iteration. So the amount of noise would also be doubling. So this time, it goes only to 65 and decryption fails. So these are basically, yeah. So as these numbers grow, the noise also grows exponentially with them. So for multiplication, it goes even faster. Let's see. And by the way, multiplicative depth and additive depth that I've implemented are accessible using these the tensor.addDepth and tensor.multiplicative depth, this one. So let's see how far the multiplicative depth can go. And okay, this goes to 18. So this time I'm just adding once. I'm multiplying once with once. So I can easily compare what the decrypted result, if the decrypted result is in fact once only. So if it is anything other than one, we know that the decryption isn't functioning well. So for a key size of 1024, it typically breaks at 18, 19, and 20. And so what we need to do to work around this, the buildup of noise is when the noise builds too much, we need a refreshing mechanism, which essentially clears up the noise. So we can do it multiple ways. We can either just decrypt the tensor and encrypt again with the same key, which is what I've done here. And the other thing is bootstrapping, which is yet to be implemented. I'm working on that one. So for right now, I'll demo the simple decryption and encryption again with the same key thing. But this is, of course, very insecure as decryption is being performed on the client side only. So I did mention this to Andrew, and from what I know, this decryption, if this is what we do before bootstrapping can be implemented, this should be done in the Sona in the capsule. So decrypted tensors wouldn't be accessible in that way. So after refreshing, it will be able to go beyond 18, I hope. Yeah, see. So if we see here, so I checked if the multiplicative depth goes above 18, just refresh the tensor here and refresh it by decrypting it and then re-encrypting it, reforming it into a failure tensor, which basically encrypts it with the same key that we defined way above. So so basically we just need to find out what these thresholds are, this 18 value for multiplications and additions. Also, another thing that needs to be done as of now is this example works for multiplicative depth and the above examples work for additive depth. But if I say add C plus C here and then multiply C with another tensor B. So after the most recent multiplication, the additive depth right now becomes 0. So we actually need a unified noise tracker that we can use to reliably predict how much of total noise the tensor each encrypted number contains. So yeah, that is still a work in progress.
Awesome.
Great job, man.
Sweet.
Thank you.
Cool. That's all the demos we have. Andrew, what do you want to add?
Man, only that it's gotten dark in the time since we started. Yeah, and fewer fighter jets.
I'm sure an ironic joke about noise from that.
Indeed. So great job, everybody. And we'll be getting another kind of an update on Pi BV and Pi Yashi offline in a separate video that's uploaded from just in as with all these demos, sometimes we'll have some internet issues or something like that. So we'll expect more demos coming online from what?
Devashri.
Oh yeah. But also we have a few more coming from several contributors with respect to things that either weren't quite ready or internet connections got in the way, and I think that we'll continue providing these demos. Some of them, it might not be your area of expertise to the extent that it's a really broad platform, But I do hope that it adds a little bit of clarity to kind of what's going on in the rest of the project. You know, in JavaScript land, we're trying to take the work that we've done in Python and convert it to JavaScript, is what Robert was showing us. It's also, and what we just saw is the ability to track noise growth in our encrypted tensors, which is if you're familiar with homomorphic encryption, is a really big deal, and to be able to automate that and make that just something that's baked into tensors, so you don't have to worry about it, is very, very good. And then of course what Adrian was demoing allows our smart contracts to run, you know, as much as 20 times faster than they would on the normal Ethereum blockchain. So the maturity of that project is really, really important to the longevity of this one. So yeah, lots of great progress going on. And if you're interested in joining one of these projects or another one, definitely check out the big list that's in the announcements channel. Yeah, if ever you're wondering about how to get started into the OpenMined project, there are really 3 ways. One is to jump into the announcements channel and contact a project's point of contact, or their POC. And then the second way is for you to look into the issues on GitHub and find a project that you can join on your own. And the way to join one of those projects is simply just comment on the project, or on the GitHub issue that you are interested in working on, and you're picking it up, and that allows other people to know that you're working on it and to potentially collaborate with you as well. And then the third way to get started with the project at OpenMined is simply to reach out to one of the core contributors. So if you see someone on one of the GitHub teams that's on one of the committer teams that's merging pull requests, they usually have really good visibility for projects, and of course you can always reach out to myself. So great job everyone, and yeah, I look forward to seeing the demos next week.
My mind is blown that we're at 1,100 people in Slack. That's ridiculous. That's over like double. I mean, it's insane. Thank you, Suraj, for that little.
Yes. Oh my goodness. Thank you so much, Suraj Raval, for taking the time to create a video. And also, I mean, there's several other videos that he's referenced us in before. So very grateful for that. Thank you for all the Twitter activity and the several blog posts that were done this week. Yeah, overall, just fantastic progress, and very honored to be in the top trending repositories on GitHub, even this week for a little while higher than projects like TensorFlow and PyTorch, which is those are big guys. Obviously, they have a lot more stars in general. Yeah, yeah. Obviously, they're. Well, I mean, it was a big week, but yeah, very, very excited to see where this is going, and yeah, thank you for everyone for contributing, and for all the pull requests. I mean, hundreds of pull requests that have come in since we've started. So very grateful.
We'll be working on a new marketing website. We'll have more updates on that throughout the week. So we're going to be rolling on something a little bit more flashy than what we currently have. Maybe a little bit more better explained than what we've currently got. So anything else?
Check out the newsletter. The first edition of the newsletter should go out this week as well. And so also, if you're watching this video and you're interested in the project, but maybe not interested in contributing code and just want kind of bi-weekly updates, a newsletter is a great way to kind of get those. So other than that, I think that's it for me.
Rock and roll. All right. Well, that's number 3. Thanks, guys. Appreciate it.
Bye-bye.
Bye.
Bye.